Welcome, Professor Bright here, and we are going to continue our study of trig and look at a few necessary identities and, well, formulas perhaps. And so we're going to talk about angle addition and difference, double angle and half angle in this video series. So there's effectively three big formulas that you need to know. And there is a fourth one which is very closely related to one of the other ones. We will see that when we get there. Okay, so there's going to be 4 videos, and so when we've studied trig so far, there's things that we have skipped, things that you might normally think about when you're working with different classes of functions. For instance, are trig functions associative? So for instance, if I think of, okay, so given theta as an angle, for associative, that is something like if we do sine of theta plus cosine of theta plus tangent of theta, okay, and I say do the addition of the first two first, is that going to be the same as if I have, sine of theta plus cosine of theta plus tangent of theta, where I add the last two first? That seems to be logical and adhere to all the rules, so that seems fine. And furthermore, if I change these all to multiplication, does that matter? And the answer is no, so it actually ends up working for both addition and multiplication. Commutative, so this is something like if we have cosine of theta times sine of theta, is that equal to sine of theta times cosine of theta? That one, yep, that ends up working. And you can also do the same thing with addition. So if you have cosine theta plus sine theta, and so this works largely in part because we remember that cosine and sine output real numbers, and so you can add, subtract, multiply, or add and multiply, really, real numbers in either order. Okay, now distributive, if you don't remember quite what that one is, this is saying like if we have cosine of, we'd have to have, theta 1 plus theta 2, is that the same as cosine of theta 1 plus cosine of theta 2? So you can see I would effectively think, oh, I can distribute cosine over to each of the angles, and so is this true or is it not? I don't know. So let's look at an example. Okay, when we're unsure, start with an example, see if it works for the example. Okay, so we have sine of pi over 2, right? Is that the same as sine of pi over 4 plus pi over 4? Okay, well, sorry, this is true. Okay, so this is true. And the question is this the same as what's over here? So effectively, we're saying, if we have sine of pi over 4 plus pi over 4 like this, is that the same as sine of pi over 4 plus sine of pi over 4? Okay, well, we know from experience sine of pi over 2, that's 90 degrees. Sine of that is 1. Is that equal to, and then sine of pi over 4, we should recognize this as root 2 over 2 plus root 2 over 2. Okay, and so then at the end of the day we get 1, and then on the other side we'd get 2 root 2 over 2, which is the same as root 2, and those things are not the same. So it looks to be that this distributive property does not work. Okay, but so then we can't really use the distributive property, but there's another way to get around this. And the Greeks were, they loved geometry and trigonometry. That's where trig actually came from, was the Greeks. And so they came up with and did extensive proofs using geometry of the angle addition and difference formulas, which you can see here in green. Okay, so yes, these are things that you are going to have to know, but I mean, particularly when you go into calculus, say, because you end up using these identities frequently. So if we have sine of an angle, and I just want to clarify the notation, so there's a plus and a minus here. You can't have both simultaneously. It's one or the other. It'd be sine of u, cosine of u, and then plus minus cosine of u, sine of v. So when you normally this is condensed notation, it would say that if you have the plus, and I'm going to highlight it here, if you have the plus here, you'd have the plus here. So the tops go with each other. So in other words, it'd be sine of u plus v is equal to sine of u cosine of v plus cosine of u sine of v. Okay, so the pluses go together. Similarly, if it was minus, you would just swap out the pluses for a minus, and vice versa. Now, with cosine, you notice that the signs switch. So you have plus and minus here. You have minus and plus here. So make sure to get those corresponding with each other. Okay, and then tangent, similar things happen here. I will tell you that of all these, tangent is the one that I use the least. So if you had to focus any brain power or brain space on memorizing these, I'd say focus on sine and cosine, because again, you can get tangent from sine and cosine. Okay, so just to put these skills to use, we're going to do some examples. Okay, so sine of 75, and then we want to find the exact value. So this is not punch it in your calculator, get a decimal. This is like find it in terms of square roots. And then we have another example over here. Okay, I want to do the first one with you. You get to do the second one. So sine of 75, I want to think about two angles that I'm very familiar with that can add or subtract to 75. And so I want you to pause the video and do a little bit of thinking. What two angles are we well aware of that can add or subtract to 75? I think you can use 30 degrees and 45 degrees. Okay, perhaps you thought of a different one, and that's perfectly fine. Okay, so and so now I can say, okay, this sine of 75 is the same as these two. Oh, but that's right. That's an identity. That's the sine of u plus v. So that I can write out as sine of 30 cosine of 40, and I'm 45, and I'm omitting the degree symbol. Yeah. I know I should have it. Cosine of 30 sine of 45. Okay, and so now if you're doing this without a calculator, right, you maybe need a little triangle here. So I know that this is 30, this is 90. Okay, and then I know this is the ratio I use is 1 to 2 to square root of 3. So then sine is going to be 1/2 times, and then this is square root of 2 over 2 plus cosine is root 3 over 2 times root 2 over 2. So then in total, what do I get? I get root 2 plus root 6 over 4. Okay, just simplifying that. And if you're not unsure of that algebra, please pause the video and try it out. Okay, for this next one, I want you to try and use an identity here to make your life simpler, and then resume the video when you're ready. And here's the solution. The first thing is recognize that this is actually just the cosine identity. So you have cosine, cosine, and minus sine, sine. So then that corresponds to adding the 7 and the 8. So that's 15. And then 15, now I want to find the exact value of that. Well, that is 45 minus 30 degrees. And so then now I'm using the cosine identity again in the other way. So kind of a fun problem. And you get 45 30 plus sine of 45 sine of 30, and lo and behold, you get the same exact answer as the first one. So that's kind of fun. But moral of the story here is to remember to just use identities, have them on a little note card or cheat sheet, something like that, and then use them appropriately. When you are ready for the quiz, the video quiz for this section, the passcode is going to be sum, diff, double, I gotta spell it right, double, and then half. Okay, the S is capitalized, I should say. S is capitalized, D is capitalized, D is capitalized, and H are all caps. So those are going to be in caps. Okay, everything else is lowercase. All right, so attempt that video quiz when you're ready. Be sure to watch the rest of the videos too.